We have this idea that innovation is some kind of lightning bolt moment, right? That it's all about creating something completely new from scratch. But what if I told you that the real secret, the one that top engineers use every single day, doesn't start with a blank page, but with a perfect copy? Think about it. From the first day of school, it's drilled into us. Don't copy. It's the ultimate academic sin. But in the professional world, is that always true? Is copying always cheating? Well, here's the twist. In professional engineering, copying isn't just not cheating, it's literally step one. It's the mandatory starting point for all real innovation. And it all comes down to this one core idea. This is the mantra that drives everything. You cannot meaningfully improve a design you do not fully understand. To make something better, you first have to master it, inside and out. So, how does this actually play out in the real world? Well, let's walk through a project that puts this whole concept to the test by taking a classic arcade cabinet and turning it from a simple box for gaming into a serious engineering challenge. This whole process, this art of the copy, it has a name: reverse engineering. And look, it's not just about taking something apart with a screwdriver. It's a deep, almost forensic analysis to uncover a product's secrets, not just how it works, but why it was designed that way in the first place. And this isn't just some abstract theory. We're actually going to follow a high school engineering project where students used the exact same professional workflow to reverse engineer and then totally redesign a tabletop arcade cabinet. Now, this is maybe the most important point to get. We have to draw a hard line between mindless copying and reverse engineering. Mindless copying is just imitation without any real understanding. But reverse engineering, that's strategic deconstruction. It's taking something apart for the purpose of improving it. One is plagiarism, the other is research. So, how do the pros actually do it? Well, they follow a really clear three-phase workflow that reliably turns that initial copy into a brand new, better creation. Let's break it down. Okay, here it is. It starts with an exact digital recreation. Phase 2 is all about evaluation and justifying the need for a change. And finally, Phase 3 is the redesign. But it's not just guesswork. It's driven by specific parameters. Let's see how they all connect. Phase 1 might sound easy, but it requires incredible precision. The goal here is to create a perfect digital twin of that arcade cabinet inside some CAD software. And I mean perfect. Every single panel, every angle, every dimension has to be exact. No shortcuts. But why? Why go through all that trouble? Well, because it forces you to get inside the head of the original designer. You start to see the constraints they were working with. You understand the choices they made about proportions and ergonomics. And maybe most importantly, you create a perfect, reliable baseline that you can measure all of your future improvements against. And get this isn't some rogue technique. This meticulous copying phase lines up perfectly with the define the problem and research stages of the formal engineering design process. It's all about gathering the hard data before you even dream of making a single change. All right, on to Phase 2. You've built your perfect digital copy. Now you switch hats. You stop being a replicator and you become a critic. This is when you start asking the tough questions. What does this design actually do well? Where does it fall short? And, a really important one, who does this design leave out? This is the official test and evaluate stage. It's where you take all your opinions and turn them into objective engineering judgment. You're analyzing ergonomics, stability, accessibility, everything. But the golden rule here? No changes yet. This phase is purely for analysis. And now, finally, Phase 3. This is where all that careful research and analysis really pays off. This is where true innovation begins. Because now, based on your data, you can develop specific, justified improvements. Things like, hey, what if we made the cabinet wider for 2 players? Or maybe adjusted the height so it's more comfortable for adults. But here's the reality check. Having a brilliant redesign is totally useless if you can't get it approved. In the real world, making the thing is only half the battle. You have to be able to sell it. You have to justify every single decision you made. So, the final product for this whole project isn't just a 3D model or some blueprints. No, it's what we call an internal sales pitch. It's basically a presentation designed to convince your boss or a client or a manufacturer that your changes are not just cool, but absolutely necessary. And just look at how rigorous this presentation structure is. This is not a casual show and tell. You have to start by establishing the baseline with the original design. Then you have to justify the need for change by pointing out its flaws. Then you defend every single one of your new choices with data and reasoning. I mean, this is exactly what a professional engineering design review feels like. Every decision is put under a microscope. Okay, so we've been deep in the weeds with this one arcade cabinet, but let's zoom out for a second. Why does this whole way of thinking, copy, analyze, improve, really matter? Because this is the big idea. It's fundamental to almost all innovation. You see, a project like this is so powerful because it isn't just teaching one thing. It teaches the entire design process from start to finish. You're building very real, advanced digital modeling skills. You're forced to communicate your ideas like a pro. It is a direct simulation of how real-world engineering actually gets done.
And that brings us right back to our main idea. Copying is not the finish line, it's the starting block. It's the disciplined process that takes raw technical skill and transforms it into true engineering thinking, the ability to look at a problem and systematically solve it.
So that really leaves us with one final thought. Just look around you for a second. At your desk, in your car, in your city. What's something out there that you could reinvent if you just took the time to truly, deeply understand it first?